Welcome back, everybody. We are now on to Lecture 10, Part 2 for Michigan's Geology. This is actually a pretty extensive topic, but we're just going to be getting into a brief introduction of a lot of the different lithologies across Michigan and sort of Michigan's geological history. The idea behind this is to really just give you a good long list of fun places to visit in Michigan and give you enough background knowledge to be able to interpret some of the geology while you're there. So first of all, the geologic history of Michigan has been pieced together from a collection of a few different types of data, but mainly from things involving digging. We have a lot of cores from both water wells and oil and gas wells. A relatively small number of outcrops across the state, so places where bedrock is exposed. And then areas where we've done a lot of digging, not just drilling, i.e. quarries. Most of the data that we've used to build a timeline for Michigan's geology come from digging data, or drill cores and quarries and outcrops, because all of that is much older rock. And we have this good thick layer of glacial deposits sitting on top of that. That glacial deposits is what you're going to see if you go out in your backyard right now and just start digging. It's the clay, the sand, the gravel, nothing too terribly exciting for usually about the first 200 feet of digging in most places in Michigan. And while collecting that kind of soil can be useful for a number of different geologic applications, it really only tells us so much about the recent geologic history of Michigan. Keep in mind that the geological time scale is a lot bigger than what we're used to dealing with in everyday life. And so the most recent glaciation, or what dumped out all of that glacial sediment, really wasn't that long ago in geologic time. The Michigan Geologic Repository for Research and Education, fondly referred to as McGree by locals, is part of Western Michigan University in Kalamazoo, Michigan, and it houses all of Michigan's subsurface data, or nearly all of it. So what is subsurface data? These are mainly drill cores. So anytime that a water well is drilled, or in most cases where we have even better samples from oil and gas wells, they get put into cardboard boxes and usually end up in somebody's warehouse. It sits there for a while somebody looks at it, analyzes it, gets samples from it, things like that. And then once they're done with it, it takes up a lot of space. It's really quite heavy, and most companies don't want to deal with it anymore, but it's still valuable to archive that data, so it ends up here in Kalamazoo at the Michigan Geologic Repository for Research and Education. Because this is part of the university, it allows for a lot of different studies to be done on any number of these cores from all over the state of Michigan. And as of right now, they are housing about 500,000 linear feet of core. So to set a framework for Michigan geology, we need to revisit the geologic timescale. And Michigan is kind of a unique place in the world because we're one of the few territories that actually encompass a pretty full geologic time scale, meaning we have rocks from, of course, our current time period, but also dating all the way back to the Precambrian. If we map out Michigan bedrock by their time period of deposition, we can see the youngest rocks, so in this green here for the Jurassic, youngest rocks occurring towards the center area of the Lower Peninsula, and as we move outward into that blue, we're going into Pennsylvanian, then gray, Mississippian. Moving outward further and further, we move further and further back in time. So our youngest rocks are towards the center of the state, with our oldest going further and further outward. This continues up into the UP, with moving back into the Precambrian age rocks, or our oldest rocks, in the outskirts of the UP relative to the center of Michigan. You can see a pattern here resembling that of a target, so it has those concentric rings expanding outward, and this doesn't end in Michigan. These geologies or lithologies continue out through part of the Midwest. So these rings continue out. It's just that that's where our state line happens to be. And the geology has nothing to do with the state line in this case. This ringed or target-like pattern is a result of the topography of Michigan, or the shape of Michigan. Michigan is part of the Michigan Basin, which is a giant soup bowl-like structure in the Midwest. So it encompasses a bit more of Michigan, but this is a side profile of this same thing that you're looking at here. So if we took Michigan, cut it along this line, and then ripped those two pieces apart and looked at them sideways, this is what we would see. Mind you, those Jurassic rocks in the middle, Mississippian, moving outward but also downward, we're seeing older and older rocks. And so this bowl-like structure essentially over time has been filled up layer by layer until we get to our top flat-like land with all of our glacial deposits that we see today. Or at least here in Kalamazoo if we're digging in our backyards. Here you can see that same idea, just presented visually a little different. So again, this is the Michigan Basin. Here's the edge of Michigan. And we've got these concentric ring-like layers, and you can see that this doesn't go down all too deep. Those Pennsylvania age rocks, and then this upper layer penetrates a bit deeper, moves all the way out. That's really where we see the extent of Michigan before it comes to the shore. And then deeper and deeper, we're getting those older and older rocks. Basin is just a word for a large topographic low, so an area where sediment accumulates over time. And that's just because gravity will cause things to flow from high to low, so it's going to move towards the lows, or the soup bowls is going to fill up the soup bowls. And there are several basins around the world. The ones that we focus on here in the Midwest, number one, the Michigan Basin, which actually encompasses part of Wisconsin and Illinois, Indiana, Ohio, and Canada. But this entire area here, the whole Michigan Basin, shares the same geologic history. Because of Michigan's diverse geology and rich geologic history and variation of rock types, we have a number of resources, a greater number of resources than most other states. Most people are familiar with our Great Lakes being one of our top resources and tourism attractions. As part of that, we also have over 17,000 inland lakes and a plentiful groundwater resource. However, most people don't really think of Michigan right off the bat when in the conversation of oil and gas. But Michigan has a number of different geologies with great potential for oil and gas, and we've seen a good barrel production out of many of these formations. With all of Michigan's glacial deposits, those clays, sands, and gravels, we end up doing a lot of production for construction type materials. Pea gravel that's used for landscaping, sand that goes and turns into glass, clay that gets turned into bricks, so on and so forth. Michigan's also a hot spot for production of different types of salts, so gypsum, halite, and hydrite would all be examples of that. And then in the UP, we have a number of precious metals, sulfide deposits, and precious gemstones: iron, gold, copper, zinc, silver, high quality quartz, sapphire, garnet, the list goes on. So today we're going over all of these resources and more, and where you can find them, and a little bit about how they've impacted Michigan's history. So I have put together a public Google map for you guys, full of all of the points of the places that are discussed in today's presentation. A bunch of these are good picking spots if you're looking for any number of these rocks and minerals that we'll be going over, as well as just nice places to visit. Some of them include family activities, and most all of them are free or dirt cheap. The link is right there in the bottom right corner, so feel free to grab that and use it however you'd like. Through this presentation, I'll be taking you on somewhat of a visual tour through all of these points or destinations, starting with bedrocks in our youngest, moving out to our oldest, and then lastly we'll cover the glacial geology of Michigan. Jurassic Age rocks are actually the youngest rocks found in Michigan. This is in the central area of Michigan. However, we do not actually have any outcrops of this. We only know that it's there because of oil and gas drilling and coming across samples that contain fossil spores and pollens that we can date to the Jurassic Age. Most all of which is comprised of a medium to fine grain, reddish or some oxidation sandstone deposited in a fairly dry terrestrial setting. Moving outward and into the Pennsylvanian period, this is actually where we see the majority of the Lower Peninsula's available bedrock outcrop. These occur in a number of counties around surrounding central Michigan. Probably the best places to see this are a number of parks around the Lansing area. And this is comprised of several different lithologies, most of which you're going to encounter are going to be limestone, sandstone, and several scattered coal beds and lenses. The major depositional environment for Pennsylvanian rocks in Michigan was a fluvial deltaic setting, so a transitional type setting with a lot of mixed sediments, rivers, and shallow waters. Good places to see this at are going to be Lincoln Brick Park and Fitzgerald Park, right around the Lansing area. It's just a little bit northwest of Lansing. Fitzgerald Park has a ton of beautiful, massive outcrops that you can climb on in some areas. Trails following a beautiful winding river. Very nice in the fall when the leaves are changing, and you can see quite a few of the sedimentary structures that we've discussed in past lectures here, such as cross-bedding, tear pants weathering, so it's a type of weathering that produces a really jagged texture, so much so that if you sit on it and slide against it, it tears your pants, hence tear pants weathering. Rip-up class, so chunks of mudstone that have been incorporated into sandstone due to high energy depositional environments such as storm activity. And then in Lincoln Brick Park, not too far from Fitzgerald Park, you can see an awful lot of shale with potential for finding a wide variety of different fossils. The areas closer to the trails in this park are fairly well picked over, so the deeper you go, the better chances you have. But the types of fossils that have been reported here include ferns, crinoids, fish bones, and a few others. Lincoln Brick Park actually got its name because it used to be a brick production area. You can see here in the center photo with a long brick chimney. That's actually where they used to process the shale and build bricks. That's the kiln that they would use. And you can walk all around this and into the half-standing building. A lot of people like to do wedding photos and graduation photos and that sort of thing there. Very picturesque. The Mississippiian bedrock covers a large area of Michigan's Lower Peninsula. The geology here is mixed, but most all of it is sandstone, shale, and limestone. There are a few pockets of salts here and there, but this is all a result of a shallow marine type depositional system. One unique place to see Mississippian rocks in Michigan is Turnip Rock. Right on Lake Huron, Turnip Rock gets its name for its distinct shape. This is a function of weathering and erosion over time, wave action hitting and breaking off chunks of rock. People have been enjoying Turnip Rock for a very long time. Today there are several kayak tours that you can take out there and climb up to the top of Turnip Rock. And I think camping may be possible up there. That's something that I would have to check on. But when the lake is frozen over, people can walk straight up to it. No kayak needed. So you can't actually camp there, but it is certainly a cool place to visit. The Mississippian rocks house a few major salt domes or pockets of salts. One of the world's most famous of these is the Detroit salt mines. These have been in operation since the late 1800s and are still going strong today. Its heyday was in the early 1900s, maybe about 1915, where at its height it was producing about 8,000 tons of rock salt each month. As a byproduct of being in operation so long, the Detroit salt mines are actually now one of the world's safest and most advanced mines to work in. Out by Grand Rapids, the Mississippian bedrock hosts laterally extensive gypsum beds, just another type of salt. And while the Grand Rapids gypsum mines are no longer in production of gypsum, they are still used for their naturally cooled temperatures for frozen food storage, primarily frozen pizza. And then much less abundant is Michigan anhydrite. This is another type of salt where we can get this really interesting texture to it called chicken wire. So chicken wire anhydrite is pictured there on the left. That is the shiny blue and chicken wire brown pattern through it. This is when salt crystals grow and push out the surrounding dirt or clays or whatever sediment is surrounding it. And eventually, as those grains start to push into each other, they create these very thin lines of that surrounding sediment, leaving a chicken wire-like pattern. The Devonian bedrock of Michigan is another area where we have a fair number of outcrops, or areas where we can see the bedrocks, whether that's natural outcrops or quarries or islands. It is mostly comprised of fractured and karsted limestone, slate, shale, and sandstone. Hence there being a good amount of quarries in this area, they're usually pertaining to the shale and wanting to extract those clay minerals. Mostly used for construction purposes. The Devonian bedrock is where the majority of Michigan's oil and gas production comes from. This is primarily from the Traverse City Shale and Dundee limestone. So limestone is fossil bearing, so that's one interesting part about it, but the other interesting part is the one with dollar signs next to it, that being the oil and gas. So these two formations make up the Antrim gas field, as pictured in the right-hand figure, where there have been a lot of successful oil and gas wells, and the attention towards this continues to grow in the Michigan geology community. And on more recent research fronts, these same formations, because of their storage potential for fluids and gases, is being considered for carbon sequestration purposes. This is essentially where we take excess carbon dioxide out of the atmosphere, and we store it in the ground. It's a temporary solution for climate change, temporary being on the order of several thousand years. And the plus side of that is that in some cases we can make it work to where that carbon that's being taken in eventually turns back into oil and can be reused again. So it becomes a way to recycle a previously non-renewable resource. This research is in the early stages. Right now its limiting factors are the efficacy, or how much oil can we get out of how much carbon we're taking in and how that ratio compares, if it's worthwhile monetarily or for climate change counteraction purposes, and then the amount of freshwater usage in that process. Most Michiganders have heard of Mackinac Island. However, the Devonian bedrock grants us much more than just that. Michigan actually has hundreds of islands among the Great Lakes, about 12 of which are inhabited. In the northeast corner of Lake Michigan, you'll find Beaver Island, North and South Manitou Islands, Fisherman's Island, North and South Fox Islands, and a few other small islands, all of which having Devonian bedrock. There aren't a whole lot of areas where outcrops, but these are beautiful places to visit. Beaver Island in particular has several camping spots, hiking trails, and a small town with a library, a little market, stuff like that. You can take a ferry out to Beaver Island from Traverse City, and the rest of the islands are by boat. The North and South Fox Islands and Manitou Islands you can reach by canoe or kayak if you're really feeling up for it, and present a really unique opportunity for a secluded visit with Michigan's nature. Research-wise, specifically biological research, one of the nation's most famous islands is that of Isle Royale. This is within Michigan, and this island has been used historically for a lot of population studies related to wolf and deer populations and how the two commingle and affect one another, what their capacities are, how quickly deer will go extinct given X number of wolves, so on and so forth. And it works out really well for that because there's nowhere for them to go. They can't leave the island. And you can camp there too. Do know, however, that Isle Royale is actually Precambrian, not Devonian. Much like the Drummond Island on the eastern point of the UP, which is actually Silurian in age. The Silurian bedrock has a very similar composition to that of the Devonian. This is going to be our southernmost portion of the UP, and also hosts a good number of small islands within the Great Lakes. Moving northward, the Ordovician is where we start to see some lithological changes, or changes in the type of geology seen, while the overall formations are still very similar with fractured and karsted limestone, dolomite, shale, and sandy dolomite. There are also sulfide deposits in the western portion, which present a really good opportunity for mining of a long list of different sulfide minerals. The figure in the top right here displays all of the proposed mining locations for both metallic sulfides and uranium in the UP. As you can see, this is towards the western portion of that Ordovician subcrop. One mine that has drawn some controversy due to the health and human environment risks associated with sulfide and uranium mining is that of the Back 40 mine. This is situated right on the state line between Wisconsin and Michigan's UP, and it's right along the Menominee River. Here you can actually physically see that quarry where they're mining down. The process of sulfide mining can release toxic metals into groundwater and surrounding water bodies. The trick with preventing this from getting to a level where it's harmful to human health and environment is controlling the concentrations. However, things aren't always so predictable, so there is some risk and uncertainty in that production. Due to the mine's proximity to the natural waterway, the Menominee River there, as you can see in that aerial photo, the local tribes have attempted to sue the Back 40 Mining Company, to which they've lost their argument. Despite the potential for contamination that will last hundreds of years after the resources of the mine have been spent, used, and buried in a landfill. However, there's not enough data to determine specifically if concentrations have grown to a point where they are toxic, and we don't know that until it gets to that point. So we don't really know that until it becomes too late, which was why the tribe was trying to prevent the mine in the first place, or at least prevent continued mining. And that mine really has seen a lot of success in both gold, zinc, copper, silver, and lead. Mostly gold and zinc. Equal proportions, 40% gold and 40% zinc, but gold bringing in most of the cash, boosting Michigan's economy and supplying the nation with much needed metals for many of our technology, medical, and aviation needs. As we progress into Michigan's Cambrian rocks, we begin to enter some of Michigan's oldest rocks, but also what is fondly referred to as the major waterfall unit, most all of which is made up of a variety of sandstones. You can see all those sandstones at the Pictured Rock National Lakeshore, where different layers of geologic time and transitions between different types of sandstone are seen on the cliff faces, along with some very interesting and beautiful shapes resulting from wave, weathering, and erosion action. The arches of pictured rocks are a good example of what the Turnip rock that we looked at earlier once was. So eventually, this portion connecting this chunk of rock to the rest of the land will weather out, leaving us a brand new Turnip rock. The waves will erode most heavily at sea level or lake level, so right around the base here, which will eventually thin out the lower lying area, leaving that curved edge on either side or all the way around, and producing that turnip shape. Kayaking around pictured rocks is very popular. However, as weathering and erosion continues, it can be quite dangerous at times because these cliff faces continue to weaken and eventually break off in large chunks, which can cause some massive waves you do not want to be caught in a kayak. And then, of course, there are numerous waterfalls all along the Cambrian rock of the Upper Peninsula. A lot of people are familiar with or have even visited Tequamanon Falls. It's one of the major ones with the largest water flow amount. However, there are several other waterfalls all right along the Pictured Rocks area, such as Miners Falls, Sable Falls, and Munising Falls. All a little bit of a hike in to see, but definitely worth it if you're able to do so. As you can see, these are all grouped together, so if you're ever making a road trip up to Pictured Rocks National Lakeshore, add those waterfalls to your list as well. In the northernmost portion of Michigan are the Precambrian bedrocks, and this is where much of Michigan's mining history sources from. As the states were getting their shapes, Michigan was just the lower peninsula. We did not have the upper peninsula at that time, and Michigan was interested in having another port city, the port city being Toledo. So Michigan and Ohio actually went to war with one another, and as the Michigan and Ohio armies were approaching each other, the federal government stepped in and said, no, we're not going to do this, actually. Ohio, you can have Toledo, you can have the port city. Michigan, you have enough ports. And Michigan said, well, actually, I'm really upset about this. As you can tell, I was ready to go to war for Toledo. And the federal government said, fine, I'd like to offer my condolences for your loss of Toledo in the form of this very large chunk of land to the north that we now know as the UP. So that's how Michigan got its UP, and also why we have a weird diagonal line happening at our bottom state border rather than just a straight horizontal line. Shortly after acquiring the UP, Michigan sent its first state geologist, James Hooton, up there and said, figure it out, James. What's going on up there? Can we make anything out of this sorry plot of land that the government gave us? James went out there, started messing around in the woods, and eventually realized that his compass was doing some weird things, and that was because there were magnetic minerals in the subsurface, which eventually led to a lot of economic profit with a very strong mining potential. After that, Michigan wasn't so mad about getting the UP because we made a lot of money off of it, and we were able to supply the nation with much needed metals for war purposes. And now Toledo sucks. Only kidding. But we still have the UP. This mining was mainly for iron, and there are many relics left of this. In the UP, you can visit the Republic Mine. They'll let you go through the tailings piles where you can find some nice big chunks of iron ore with a couple of accessory minerals. You can also see the lake where there once was the quarry, and they have since flooded. You cannot swim in this. There are way too many metals in that water. You can also go on a tour of the Iron Mountain Mine, where you actually go down into an old mining shaft where they used to mine for iron, and you can take samples and see all the old machinery and jump in one of the old mining carts, so on and so forth. The Quincy mine is also another historic iron mine in the UP. They do tours as well, where you can do much of the same things as you can do in the Iron Mountain mine, but the fun part of this is it comes with an old west type feel town, but in the winter barren of Michigan's UP. And if you don't have time to see all of those places, but you're still interested in the iron mining history of the UP, you can visit the Michigan Iron Industry Museum. That's in Republic, Michigan of the UP. There you can get a few bits and pieces from all of the different iron mines. You can see the iron ores, all of the machinery that they've used, a bunch of the things that connect you to those miners in the past, their lunch pails, their first aid kits, things like that. Some of the world's best Biffs are in the Precambrian rocks of the UP. A Biff is an acronym for a banded iron formation, and geologists and other people, just rock enthusiasts, love these. They are alternating and oscillating, so moving like wave-like patterns of hematite, that's the darker black magnetic mineral, and jasper or red chert being that bright red. So this gives a really unique pattern, and that red that you see in the jasper is from rusting, so that's indicative of a period of higher oxygen environment, and the black is indicative of an oxygen deprived environment. So this formation actually tells us a lot about the changes that were happening with the atmosphere at the time of deposition. So this was a lot of switching back and forth in a geologically short period of time between an oxygen-rich environment and an oxygen-deprived environment. Very unstable for life. There are some amazing, huge outcrops of this on Jasper Hill, on Jasper Street, in Ishpeming, Michigan. Scattered all around the Precambrian rocks of Michigan, you can find copper deposits, and some of these get quite large. You can see that picture of the DNR officer waving his hand in front of one of the larger chunks of copper that have been found. It has some copper dioxide on the outside. That's that blue coloration that results from the copper interacting with the oxygen in the atmosphere. But if you slice it open and polish it, you see something that's pictured just below that, with that shiny, beautiful copper that we're used to seeing in some of the older pipes in the older houses, if they haven't been busted out yet. You can also find staurolite, which is this crossed-like mineral here. This is actually what its natural crystal shape is. So a singular crystal is this one hexagonal tube. And this mineral has a unique property called twinning, where it's very common for it to produce like a conjoined twin out of the sides. So all of these are in a way conjoined mineral twins, where it's two different crystals that have grown out of each other. You can also find smoky quartz and some garnet. All of these little tiny soccer ball, shiny red soccer balls in here are garnets within a schist. You can see that a little bit better in this picture. That's what they look like, but if you pull them out, they are the gemstone quality garnet. And you can also get a bunch of other accessory minerals with all of these, and even some sapphires have been reported to have been found in the Precambrian rocks of Michigan. For all of these Precambrian sites, I have marked them on that shared map. Everything that I've just talked about is generally in this area, as well as the Quincy and Champion mines up here in the Keweenaw Peninsula. That's those iron mines. But most everything for all that fun hunting is right in this Ishpeming Republic type area. And I've included specific notes for all of those points on that map as well. Where to go, what outcrop to pull over on, where you can park, things like that. While that's all fun and exciting, the UP is a bit of a drive from here in Kalamazoo, and most of what you and I see if we go out there and just start digging with the shovels we have available to us is going to be glacial till. In other words, a bunch of clay, sand, and gravel. And that's because almost all of Michigan is just covered in glacial till. This is due to the last glaciation, where glaciers from Canada, the Canadian Shield, moved down into the Michigan Basin, and as they moved further south, they began to melt out, and all of the sediment and dirt and crap that it's picked up along the way is dumping out as it's melting, which gives us all of that top glacial sediment that we have here in Michigan. Most of the information that we have on this comes from the Michigan Geological Survey, and they do have a YouTube channel as well. You guys can feel free to look those up. Most of their content involves water wells and water quality and quantity related issues. But clay, sand, and gravel isn't completely boring. We can still find some interesting things in there. And one of those interesting things, is particularly one that's received some media attention recently, is that of euperlites. Named euperlites because they were originally found and named euperlites by some rock hunters up in the UP. Hate to break it to them, but it's actually not a new type of rock. This is a fluorescent sodalite. So anytime that UV light is shown onto this, it will glow, as you can see in those pictures. Just looks like a very average gray rock under daylight, but you shine that light on it and it will glow bright. And if you keep the light on it for some time and move it away, it will sometimes just barely retain that glow. And this really gained traction after somebody found one and started calling it a euperlite, which is great because it's gotten a lot of people into rock hunting in Michigan, but that person didn't know that they do not just appear in the UP. There are actually several locations where you can find these in the Lower Peninsula as well. Fortunately for us, along Lake Michigan, specifically the southern portion and the northern portion, not so much in the central portion. There is a whole other public Google map made by someone from a Facebook group for Michigan Rock Hounds that I've included a link for here, so you guys can visit any of their particular locations. Some of those actually overlap with the locations that I've included on our class's map. Also, as part of our glacial deposits are our sand dunes. We have these all over the place along the lake shore. Our most famous ones are Sleeping Bear Dunes, and that's because those are the tallest. You can really get some air going down those if you haven't been. It's a pretty decent hike up, but it's fun to come down. It's just like the coming back up again that'll get you out of breath. But we have dunes all along the way. You know, a couple other examples of this are Warren Dunes. It's about an hour drive southwest of Kalamazoo. Saugatuck Dunes, about an hour and a half drive northwest of Kalamazoo. And Hoffmaster State Park, that's almost directly west of Grand Rapids. All of these display some beautiful sand dunes, all of which are a result of wind-blown erosion. So this sand, next time you go out to the dunes, you can notice the sorting and rounding of these grains. It's a very mature sand, meaning that all of the grains are very well rounded. That's what makes it soft for you to step on your feet. And it's also very well sorted, meaning all of those sand grains are about the same size. You don't have a bunch of gravel mixed in with a bunch of fine clays and a full range of sand sizes. It's all pretty well fine and rounded, high quartz content sand. And because of this, that high quartz content, remember quartz is a fairly hard, durable mineral. It's high degree of rounding and high degree of sorting. Our dune sands here in Michigan are actually quite desirable for horizontal fracking purposes. When a horizontal well is drilled and they fracture into the rock horizontally, those microfractures need to be held open by something, because once they're split, all of that overburdened weight will cause it to close back up if you don't have fluid or something solid actively flowing through there. So to get these to stay open, they like to use very well sorted and well rounded quartz sand. So they'll include that in their drilling fluid, put that in there, that'll hold open the fractures once all of the fluid is done flowing through, because the quartz can, if there's enough quartz there, it can withstand that overburning weight, keeping that fracture open, and you want them all to be about the same size so that it can actually hold up some strength to that weight. And the rounding of the grains themselves actually helps to disperse that weight as well. So it works really well for that purpose. But we do try to preserve most of our dunes. That's why a lot of them happen to be state and national parks here in Michigan. And we have a lot of protection and conservation laws surrounding the dunes. However, eventually, when we have some heavier winds, these dunes can get blown into neighboring properties behind these state parks. And a lot of those people don't like it when they get a bunch of sand in their grassy backyard. And so if there's enough, they can start selling it to those companies that use that. Along the shores, we can also find septerian nodules, also sometimes referred to as lightning rods. Septerian nodules are the result of mud cracks formed from desiccation and dehydration, repeated cycles of dehydration and rehydration, which are later filled with flowing water, which precipitates out and forms calcite crystals. So these are all little crystals of calcite which have grown and filled these mud cracks. And the nodule part comes from this being broken up into chunks and weathered around the edges. As you can see, they have smooth, globular-like edges or surfaces, and then being included in something else, usually loose, unconsolidated sand at our shores. Up top here are what most of the ones that we can find in Michigan look like, though there are some really desirable ones that you can find in rock and mineral shops, like these. These are from Utah, where the calcite veins are much thicker, so you can see that gray is that cracked mud and all of that pretty yellow or calcite. And then you can also get a version of this that's only from Madagascar, where that gray is the mud, but all of this black is the thick crystal filler of those veins. You can find these in Michigan by going to areas where there has been some massive beach erosion. So any place where there's a good cliff, make sure there's nothing hazardous above your head, but you start digging into the cliff base and you are likely to find some of these hiding in there. These are not to be confused, well, while these are called lightning rocks sometimes, it's not to be confused with fulgurite or lightning glass, which is a product of lightning striking a high quartz content sand and turning that sand locally into glass by all of the heat that's displaced. And in these you can actually see the path that the lightning moved through the sand. This is what they can pull up and then rinse off, and you get some really interesting glass sculptures from this. If any of you have seen the movie Sweet Home Alabama, that's kind of what that's based on. However, all the sculptures in that movie are actually very well crafted, beautiful, but hand-blown glass. It's not naturally occurring. Some geological points of interest near Kalamazoo, near with an asterisk, meaning depending on how far you want to drive, but not too terribly far. From Kalamazoo is the Dinosaur Park and the Geology Museum at Western Michigan University. These are in or next to Rood Hall, which is the Geology and Physics building. It's the one that looks like an old computer slot card where they had the punches, and that was how computers read in information. Both of which are free. They have a lot of really interesting fossil samples, most of which from Michigan, but fossils from all over the world, as well as rocks and mineral samples from all over the world. The minerals just gorgeous, with really incredible crystal habit, very large crystals. They have diamonds, emeralds, several types of quartz, agates, petrified wood, mastodon bones, the list goes on. And then the Dinosaur Park is a nice fun place. They keep adding to this. They add new dinosaurs every few months or so, but they are massive sculptures. Some of them life-size or near life-size, but anybody can come up and look at them and walk around them and take pictures. You can eat in the garden. Sometimes they'll put a projector out and play dinosaur movies. They did Jurassic Park some time ago, but all of that's free. You can go stop by whenever. They have Triceratops, Stegosaurus, a couple of raptors, and a few other dinosaurs. Again, they keep adding on to this. Their newest addition will be a 17-foot hadrosaur. That's the duck-billed dinosaur. If you drive out west to Lake Michigan, you can find all sorts of different things in the glacial outwash there, the sand. You might potentially find some fossils that have washed up after a good storm event within all of those weathered gravels. So some of the things that you're seeing in the Michigan Geology lab, like crinoids, horn coral, Petoskey, all of those you're fairly likely to find along the shore. Some good locations for that are Deer Creek Park in Van Buren, as well as Pilgrim Haven. Again, all of those marked on the map with specific descriptions as to what you can find there as well. And then if you're ever just walking around in Michigan, you pick up any old rock, most likely it's going to be sandstone and limestone, as you might have guessed from all of the time periods that we moved through. Almost all of them together are sandstone and limestone. If you get out to the beach at the right time, you can find some magnetic sand. So take a magnet out there with you if you haven't done it before. Those little wavy parts of black sand, those are magnetic minerals that are there. That is primarily hematite and magnetite, and that is a product of glacial outwash and beach erosion. So washing a bunch of fine sediment, broken down magnetite and hematite from those heavy metal Precambrian rocks up in the UP being brought down from the lake and dumped out, but also from beach erosion, which is pulling away the sand and breaking into the land, revealing layers where that same process has happened in the past. So if you haven't done so already, take a magnet out there. That's a lot of fun. Kids love that one. We covered a lot in this lecture, but believe it or not, there's an awful lot more than that. So if you ever want to know more about Michigan geology, just feel free to ask. Or if you're looking for something a bit more casual, I highly recommend joining the Michigan Rockhound Facebook group. It's a good way to really learn a lot about what kind of rocks are right around you. You can post pictures of what you found and ask other people what their thoughts are as to what it is and how it got to be the way that it is. Also, you can join the Kalamazoo Geological and Mineral Society. That's part of the Kalamazoo Library, but they put on a rock and minerals show annually where you can go and get some really good deals on rocks, minerals, crystals, anything made out of that, jewelry, that type of stuff. It's been a while since they've done it because of COVID, but last time I went there they had literal like Lowe's 5-gallon buckets full of opals that were extremely cheap. Beautiful Ethiopian opals. So just a couple of quick reminders for you guys this week. Don't forget to take the lecture quiz as always, and not as always, please remember to post your lecture, your research project topic, and the format of choice in the discussion board within Module 10. So I hope you guys enjoyed this and that you have a chance to get out to some of these places and that you feel equipped to be able to tell people where some of the rocks that you're looking at came from. So, until next time.